This is question 2 from the SACE Physics course companion from the subtopic 1.1. Here we have a ball being projected at 24 meters per second at an angle of 55 degrees above horizontal on a flat surface, and we're assuming that air resistance is negligible. First up, we need to resolve the velocity into vertical and horizontal components. So this should be fairly straightforward. We know that the vertical component is just given by v sine theta, which we have 24 sine 55, which if we substitute into our calculator, we should get 19.7 meters per second. Similarly, the horizontal component will be given by v cos theta, so 24 cos 55, which if we substitute into our calculator, we should get 13.8 meters per second. So that's very straightforward. That's more of a thanks for coming type question. Part B is a little bit tricky, so you have to work out the velocity of the ball after 1.2 seconds, which means that you need to not just work out the speed, but the velocity, so an angle will be required. You also need to understand that the horizontal component will remain constant throughout its motion. So really, all you need to do is work out the vertical component after 1.2 seconds, then add the two components using Pythagoras' theorem, then work out the angle. So here, the easiest way is probably just to use the Vovat's formulas. So here our initial speed, which we've just worked out vertically to be 19.7. We're trying to work out v. The acceleration is just the acceleration due to gravity, negative 9.8. The question tells us that the time is 1.2 seconds, and we don't care about the displacement at the moment. Now, it's using one of our constant acceleration formulas, just v equals v0 plus at. Substitute some numbers in, so we have 19.7 plus negative 9.8 multiplied by 1.2. Put into the calculator, and we should get 7.9 meters per second. So now we need to work out the speed. So here we'll draw a little diagram. So this we've just worked out this component to be 7.9. We know from before that the horizontal component is 13.8 meters per second. Therefore, we just work out the hypotenuse using Pythagoras' theorem. So v will be the square root of the sum of the squares, which if you put into your calculator, you should get approximately 15.9 meters per second. We also need this angle here, so we have opposite and adjacent, so we'll be using tan theta. Therefore, theta will be the inverse tan of 7.9 on 13.8, which we can work out to be 29.8 degrees. Therefore, our final answer will be 15.9 meters per second at an angle of 29.8 degrees above horizontal. Alright, so part C is finding the time taken for the ball to reach its maximum height. So after this point, about here, now at its maximum height, there are a few things we need to recognize. First is that the vertical speed of the ball will be 0 at its maximum height, and that'll give us the extra bit of information that we need to work out the time taken. So again, just using Vovat's. So v0, as we've worked out before, will be 19.7, and The final speed will be 0. Acceleration is just the acceleration due to gravity again. So what we're trying to work out is the time. So again, the only formula which has V0, V, A and T in it is V equals V0 plus AT, which we rearrange to become V take V0 on A. So 0 take 19.7 on negative 9.8, which if we substitute into our calculator is about 2 seconds. Finally, we need to work out the horizontal distance travelled by the ball. So now the time taken to reach its maximum height is only half of the motion, so the total time of flight will be 2 times 2 seconds, so it will be 4 seconds. And the range is just given by the horizontal speed, which is constant, multiplied by the time of flight. So we worked out the horizontal speed before to be 13.8, multiplied by 2 times 2, so that'll be multiplied by 4 seconds, which, if we substitute in our calculator again, will be 55.2 meters. Or if you use some of the exact values, you might get 55.3 meters. And there we are. We've done all parts of the question. Yeah, that's it.